Shake Table Lab by Allison and Kiley. Originally, this is what we thought our tower would look like. It shows the measurements we wanted and the basic structure. The numbers on this sketch show the restrictions that my partner and I wanted to reach. Our first week of construction included a base with 4 supports that were 2 straws lengths in height. Allie and I continued on with the first 2 stories and added cross supports, along with a base for each floor during construction number 2. For construction number 3, we added paper flooring and started the 3rd level of our tower. We needed to make sure that our tower was within the height limit before we finished the top level. Finally, we finished the 3rd floor and roof of our tower. We also added embellishments to make our tower unique. In this construction sketch, we showed the dimensions and measurements of our tower. While doing this, we made sure that the height was within the restrictions. The number on the sketch makes sure of that. The measurements of the sketch changed over the process from the original building sketch measurements. Here, we tested the strength of our tower with a static test. This included placing 4 of the sandbags we would be using in the shaking on each floor. As we were building our tower, we tried to put in as much extra support as we could without breaking the straw limit by adding extra straws to our cross supports. The strongest parts of our tower, in our opinions, were the double poles that supported the corners and the 3 straw cross supports that held up the tower. In Allie and I's opinion, these are the weakest parts of our tower. We think this because the top as well as the 3rd story don't have cross supports or double straw poles. Tape was strongly needed in this project to try and hold the straws up and together to make it stronger. While we were making sure to use enough tape to hold it together, we tried to avoid creating any rat's nest, which consisted of a giant ball of tape. We were given extra supplies for this project. The extra supplies consisted of paper for the roof and flooring, tape, which we used to hold everything together, and extra straws to create the roof. Our first video is showing how our shake table tower was doing at 8 sandbags, which is directly in the middle of the testing because our tower collapsed at 16 sandbags. Our second video is showing our tower collapsing in slow motion at 16 sandbags. As you can see, our tower broke at the bottom cross supports and corners. An XYZ graph shows 3 things: the up and down, the side to side, and the forward and backward motions that a building has during an earthquake. The green line is the x-axis. It represents the side to side motion. The orange line is the y-axis. It represents the forward and backward motion. Finally, the blue line is the z-axis. It represents the up and down motion. Although the scale shows different measurements of motion, the spread of numbers on the different axes measure larger or smaller than the other axes. These are my thoughts on our shake table tower. Hello, my name is Kiley, and these are my thoughts on Allison and I's shake table tower. Our shake table tower supported 16 sandbags, 8 on each floor. Therefore, it collapsed at 18 sandbags. Our building failed at the 1st level corners and cross supports. At 18 sandbags, our tower was flexing a lot, and finally, the weaker points, which were the corners, gave in to the weight of the sandbags. I think if I could have changed something about Allie and I's tower, I would put some straws underneath the first floor and strengthen the corners more, because the first floor is where our tower collapsed first. I learned that in order to live in a society that is an earthquake zone, you need to put a lot more thought into building a city. You can't just go for the looks on the outside of the buildings. You need to make sure it's sturdy to keep the people inside it safe. I also learned that you need to have a lot of extra supports and a wide base to get the mostly successful results. I really enjoyed being able to have the responsibility of building our own tower with our own ideas. I loved experimenting and brainstorming the best ideas to get the best results with my partner, Allie. Thank you. These are Allie's thoughts on our Shake Table Tower.
Hi, my name is Allison Yen, and these are my thoughts on Kiley Keating's and my Shake Table Tower. Our Shake Table Tower supported 8 sandbags on each floor for a total of 16 sandbags during the final test. Our building failed on the cross supports, which were very weak and were supported only by tape. If I could have changed something about my tower, I would put some straws below the first floor and to strengthen it, so the floors would not collapse. I would also change the cross supports so they would be more sturdy. I learned that triangles are very strong shapes and are the strongest for supporting a shaking building. I also learned that straws are actually stronger than you would think. I learned that to make a good tower that would stand in shaking, you need to have a wider base and a smaller top. What I enjoyed about this project was learning more about architecture that I never would have pursued if I hadn't done this Shake Table Lab. I also enjoyed brainstorming and making this tower with my friend Kiley.